Alrighty, in this video, we are going to be talking about the fundamental theorem of calculus, but before we do that, this first part is going to be on properties of definite integrals, and then we'll talk about the fundamental theorem of calculus on the second part. But sometimes whenever we are dealing with functions, we might need to integrate them and find the area below the x-axis, and the area below the x-axis actually represents negative area. So the total area from A to B for some curve is actually called the net area, where we are going to be adding area from above the x-axis and then subtracting area below the x-axis. Here are some properties of definite integrals that you will need to know. So the first one, if you have the integral from a to b f of x dx, that's also saying the negative integral from b to a of f of x dx. If you have some constant, and let's say that you want to find the area from b to a, here's your constant right here, and then here's a to b. It's basically your rectangle. So b minus a represents this length right here, and then c just represents this right here. So that's your rectangle. If you're taking the integral from a to a, that's really nothing because it's really nothing. You're not doing anything there, so it's 0. If you have a constant, you could take that out up front. So you have the integral from a to b, f of x dx. You could add integrals. So if you have f of x and g of x, then you could split them up into two separate integrals. And then you could combine integrals into one. So if you have an integral from a to b and then the integral from b to c, that's going to give us the area or the integral from a to c. If f of x is even and you want to find the integral from negative a to a of f of x dx, then that's going to give you 2 times the area of 0 to a, whatever your a value is. And if f of x is odd, then the integral from negative a to a f of x dx is just going to be 0. All right, so let g prime be a function given below, that should say below, on the closed interval from -2 to 16 consisting of 4 line segments, and we want to find the following. So we want to find the area from -2 to 5 for number 1. So that is going to represent this thing right here. We have this area in green, which I'm going to write the integral from -2 to 3 g prime of x dx. And we're going to add that to the area from 3 to 5. So the integral from 3 to 5 g prime of x dx. And we are just going to use basic geometry to help us. Well, if the first one from -2 to 3, this is just your basic triangle. You have a base of 5, and then you have a height of 3. For the second one, from 3 to 5, you have a basic triangle again. You have a height of -2 and a base of 2. So remember that since this is negative area right here, it makes sense for me to have a negative area right here because your height is negative. Okay, we are going to evaluate that. So this is going to be 15 over 2. And then on the second area, this is just going to be -2. Evaluate that, and you are going to get 11 over 2, or 5.5. We're going to do the same process for the area from 3 to 16 right here. So the area from 3 to 16 consists of a couple of things. We have this area from 3 to 5, which we already found from number 1. We have this area that is kind of covered by the semicircle, and we'll talk about what that means. We have this rectangle, and then we have this triangle. So if I were to write this is going to be the integral from 3 to 5, g prime of x dx. And then this is going to be from 5 to 9, g prime of x dx. Red is going to be from 9 to 12, G prime X dx. And then we have orange, so 12 to 16, G prime X dx. We'll already know from number 1 here that the integral from 3 to 5, or this area right here, was -2. So that's what I'm going to have for the first part. So that's already easy. Now, for the second part, where we are finding the area from 5 to 9, that gets a little bit wonky because we have this semicircle that is on it. So what we're going to have to do is find the area of the rectangle first and then subtract it from that semicircle so that we have this net area. Thinking about the area of the rectangle, that is going to give us -8, since we have a height of -2 and then a base of 4. And what I'm going to do is add the area of this semicircle, because we do not need this. I don't want that. So that's going to give me 1/2 pi r squared, so 2 squared. And that's going to give us 4 times 1/2, which means that this eventually becomes 2 pi. Okay, the area in red is just a rectangle, so that's a 3 by 3 rectangle, so that's going to give us 9. And then the area in orange is going to be 1/2. Your base is 1, 2, 3, 4, and then your height being 2, which means that the area of that is going to be 4. So then you have -2 plus -8 plus 2 pi plus 9 plus 4. And if you add all of that together, you're going to get 2 pi plus 3. Okay. Number 3 says we want to find the integral from 3 to -2 of g prime of x dx. Now remember, whenever we were talking about area, we want to go from left to right. This is not in the form of left to right. This is right to left. We don't want that. So instead, we are going to rewrite this so that it is the integral from -2 to 3, g prime of x dx. So I could find the area from -2 to 3, which is this triangle right here. And we already found that triangle from number 1. That was 15 over 2. So this is going to be 15 over 2. So you get -15 over 2 as your answer. Now, you might think, well, this area is above the x-axis. You are correct that it is above the x-axis, but as we are looking at this right here, because I have a property, I was initially going from right to left right here, this would represent a negative area if I were to go from right to left. So that's why this right here is -15 over 2. Number 4 is the integral from 0 to 5 of g prime of x dx. So kind of have 2 parts once again for number 4. I have 0 to 3, and then I have 3 to 5. I already know what 3 to 5 is, because 3 to 5 from number 1 was -2. So the only thing that I really need is the area from 0 to 3, and that is just this part right here. So 1/2, 3 times 3. 1/2, 3 times 3, which gives us 9 over 2, minus 2, which gives us 5/2, or 2.5 as my area from 0 to 5. All right, now that we have looked at area in the geometric way, what if they already give us the area for a couple of the integrals? So -1 to 8, 4 to 8, 4 to -1, -1 to 8 of these functions right here, and we want to evaluate. So looking at number 5, where we want to find the integral from -1 to 4 of h of x dx, let's think about what is happening between h of x right here. So I have these two functions that represent h of x. And it might be helpful to maybe create a little number line to see what's happening. So here, from -1 to 8, this whole thing is, this whole thing is 16. But from 4 to 8, this whole thing is 5, which means that from -1 to 4, it's going to be 11. Now, how can I write that using calculus notation? Well, I'm going to have the integral from -1 to 8, h of x dx. And remember, that is equal to -1, the integral from -1 to 4, h of x dx, plus the integral from 4 to 8, h of x dx. So then -1 to 8 represents 16. This is what we're trying to find. And then we know that this was 5. So that's how we get the integral from -1 to 4 being 11. Okay. We're going to do the same thing with number 6, where we have the integral from 8 to 4, and it is from -2 h of x plus 1 dx. I am going to split this up into two integrals because I have two terms right here. So I have the integral from 8 to 4 of -2 h of x plus the integral from 8 to 4 of 1 dx. Now, remember that we kind of want to go from left to right. So here, instead of 8 to 4, and this is being 4 to 8, I'm going to flip it. Same thing with this one. So for this one right here, where we have the negative integral from 4 to 8 of -2 h of x, I am going to bring out the -2 up front. So a negative and a negative will make a +2 right here. So now I have 2 times the integral from 4 to 8 h of x, and we know that is this right here, which is 10. So this part right here is 10. We also know that this one right here, the integral from 4 to 8 of 1 dx, is a rectangle from 4 to 8, and it has a height of 1. So that's going to give me 1, 8 minus 4, or 4. And don't forget about the negative here that I forgot, because this is 4 to 8, and this is 8 to 4. So then I get 10 minus 4, which is 6. Okay, for number 7, once again, I am going to change this so that my lower bound is a. So I have the integral from -4 to 8 of k of x dx. Once again, we could probably figure that out in terms of what I know so far here. So I have -1 to 8. And then I have, that should not be a -4. That should be a 4. This should be a negative right here. And then I have -1 to 4, and then 4 to 8. I'm trying to figure out what this is right here. I know that -1 to 8 is -2 overall. And I also know this right here. the integral from 4 to negative 1 is 2k of x dx is equal to 6. So what I'm going to do here is bring out the 2. And what I'm also going to do after I bring out the 2 is divide. So now I have the integral from 4 to negative 1 k of x being 3. And then, because it's not from left to right, I'm going to flip it so that I have negative 1 to 4 right here, which means that the integral from negative 1 to 4 k of x is negative 3. So this is negative 3. The whole thing's negative 2, which means that my integral from 4 to 8 is 1. Now, this is saying the integral from 8 to 4, which means this is the negative integral from 4 to 8. So we know that this is 1. So this whole thing's 1, which means that my answer is just negative 1. Now, how can I find that? Using calculus notation. So once again, I have negative 1 to 8 k of x dx is equal to the integral from negative 1 to 4 k of x dx plus the integral from 4 to 8 k of x dx. And we know that for number 7, this looks like this right here. So we know that this we found out was negative 2 from negative 1 to 8. Then from negative 1 to 4, we found out that that was negative 3 right here. And then here, from 4 to 8, we knew that this was 1. So then the negative integral from 4 to 8 k of x dx is negative 1. Oops. I'm going to delete that since it's on video anyways. So negative 1. Same thing for number 8. So go ahead and try this one on your own. And your answer here is going to be 24. All right, on the next video, we are going to be talking about the fundamental theorem of calculus. So we are going to finish up 9 through 13 on the next video.